Now here's something that might make you feel a bit uneasy at first glance. We've got powers of 2 with exponents in the hundreds, which seems completely intractable. But mathematics has this wonderful property where the most intimidating problems often have surprisingly elegant solutions. What we're about to see is a perfect example of how the right perspective can transform complexity into simplicity. Before we dive into the solution, it's worth taking a moment to appreciate just how impossibly large these numbers are. This will help us understand why we need to think differently. Just to get a sense of scale, 2 to the 999th power is absolutely massive. This number has over 300 digits. To put that in perspective, the number of atoms in the observable universe is only about 10 to the 80th power. So clearly we can't just brute force this calculation. We need to be clever. Here's the key insight. Instead of getting overwhelmed by these enormous numbers, we're going to focus on the patterns and structure. Let's start by looking at what's inside the square root. Right away, we can spot something useful. We have two identical terms here, so we can combine them. So now we have 2 to the 999th power plus 2 times 2 to the 998th power. Now here's where things get interesting. These terms might look different, but they're actually built from the same fundamental piece. Notice that 2 to the 999th power is just 2 times 2 to the 998th power. Let me rewrite this to make the pattern more obvious. Perfect. Now we can see we have two identical pieces. This means we can factor out the common term. When we factor this out, we're left with 2 plus 2 times our building block. Well, 2 plus 2 is just 4. And since we're working with powers of 2, let's write 4 as 2 squared. Now we can use that fundamental rule for exponents. When multiplying powers with the same base, we add the exponents. And just like that, all that complexity collapses into something beautifully simple, 2 to the 1000th power. Now, when we substitute this back into our original expression, something magical happens. The square root of 2 to the 1000th becomes 2 to the 500th power. So we have 2 to the 500th power in the numerator and 2 to the 498th power in the denominator. Using the quotient rule, we subtract the exponents. 500 minus 498 gives us 2 squared. And there it is. 4, just 4. After all that complexity with numbers having hundreds of digits, we end up with the simple integer 4. But you might be wondering, is there something deeper going on here? I mean, what if we had started with different numbers? Was there something special about 998? Or is this simplicity a consequence of some deeper pattern? Let's find out. What if instead of 998 we use any even number n? The structure of our problem stays exactly the same, so let's see what happens when we work through the algebra. Just like before, we combine the two identical terms. And again, we rewrite the first term to reveal the common structure. Factoring out the common piece gives us 4 times 2 to the n. Since 4 is 2 squared, this becomes 2 to the power of n plus 2. Taking the square root gives us 2 to the power of n over 2 plus 1. Now for the final step, the quotient rule. We subtract the exponents in the numerator and denominator. Now watch what happens to our variable n. This is the beautiful part. Look at that! The n over 2 terms cancel each other out completely. They just disappear. What we're left with is simply 2 squared. So the answer is always 4, no matter what number we started with. The specific values don't matter. It's the underlying structure that determines the outcome. This is one of those beautiful moments in mathematics where seemingly complex problems reveal their elegant simplicity once you know how to look at them.